and welcome to our last lesson in Chapter 1. Today, as you can see from the title of our lesson, we are going to be looking at the area and perimeter of triangles and rectangles. We also are going to talk a little bit about circles, so that should be up there as well. We want to just start you out with a quick review of what it takes to be a polygon. The polygon is the larger family of triangles, rectangles. All of those are part of this group called polygon. And I'd like to begin by saying that there are three things that it takes for an object to be considered a polygon. First off, the edges or the sides must be straight line segments, which is kind of redundant. Sides must be line segments. To be a polygon, it has to be a closed figure. That is, it has to enclose space. And lastly, the sides can only intersect at their endpoints. Those are the three criteria to be considered a polygon. Some of the figures shown here are polygons, some are not. Using these three criteria, I would love to have you decide whether yes or no you believe that they're polygons. So if you would pause the video for a minute, and we'll catch up on the flip side of that. Okay, I've marked those that I think are polygons, and those with a Y, and those that are not with an N. And as you can see, the only two I seem to have excluded are this oval and this odd shape. I don't think there's a real name for that. Neither of those fit the criteria. Sides must be segments, straight line segments. They both have some curvature. Now, some of the other polygons you may be surprised at. However, this one, it does have straight edges that meet only at their endpoints. It is a closed figure. Same thing is true here. What makes these two polygons different from the other is the fact that this one has, see how it has pieces that go in towards the center instead of everything pushing toward the outside? This one too has pieces that go back in on themselves, is perhaps a way to say it. There is a term for that, and I'd like to have you look at this pullout. A convex polygon, and that's the type that we'll talk about most frequently in class, is always pushing out. What I mean is, if you consider this to be the center of the polygon, every vertex is pushing towards the outside. Everything is pushing out. Convex, push out. Concave, a way to think about it is they cave in on themselves. That is, it has some edges that go back in towards the center. Convex polygons are where we will spend our time in this class. All right. As we're going through this class, I will be asking you to remember the names of some of the polygons, and this is not a bad place to start. This one, four-sided figure, I can't tell if it's right angles or not. Looks like all the sides are the same though. So it maybe is a square, but for sure I know it's a rhombus. Rhombus have sides that are all the same length. This guy has 1, 2, 3, 4, 5, 6, 7 sides. There is a name for that. It's either a septagon or a heptagon, depends on who writes the book. Let's see, this one has 1, 2, 3, 4, 5, 6 sides. Do you remember that one? One of the ones that we'll get very familiar with. That is a hexagon. We have a 1, 2, 3, 4, 5-sided figure here. That is a pentagon. Penta, 5. This one, 1, 2, I'm going to mark them. 1, 2, 3, 4, 5, 6, 7, 8. Most of us can remember this one because this is like a stop sign. It's an octagon. This one has 4 sides. That makes it a quadrilateral, but 2 of those sides appear to be parallel. This guy's a trapezoid. A lot of the quadrilaterals have their own special names. Rectangle here, and this one of course is a triangle, or I've seen in some books a trigon. All right, Let's move on and talk a little bit about areas and perimeters for triangles and rectangles. A polygon's perimeter, folks, is the distance around it. Perimeter is the distance around the edges. All you have to do is add the lengths of the sides together. So add the lengths of the sides. And you should remember, perimeter is a measurement. It needs to have a unit on it. I had a teacher once who said we shouldn't ever have any naked numbers. They need to have units on them. We're asked to find the perimeter of each figure. I'd like us to start here because this is the one that looks the scariest probably. I will tell you that one of its sides we can find in the coordinate plane just by counting. This side is 1, 2, 3, 4, 5, 6 units long. As long as it's a vertical, exactly straight up and down, or horizontal, you can count the length. As soon as you start getting something that's slanted, or oblique is the name for that, then you have to think about doing a little Pythagoras. This is 2, this is 1, 2, 3, 4. 4 squared is 16. 2 squared is 4. So this side is the square root of 16 plus 4, square root of 20. This side, let's see, looks like over 1, 2, 3, 4, and 1, 2, 3, 4, 4 on both sides here. So let's see, 4 squared is 16. 4 squared is 16. 16 and 16 is 32. So this one is the square root of 32. Square root of 20 here. Square root of 32 here. I'm going to take my calculator and add those, and I'll get back with you for a perimeter. Alright, I did the arithmetic. The square root of 20 is about 4.5. The square root of 32 is about 5.7. And that gives us a perimeter of about 16.2 units in the coordinate plane. I'd like to have you pause the video now and come up with a perimeter for this rectangle and a perimeter for this hexagon. Okay? Notice, I just want to remind you, hash marks here. What do those hash marks tell you? Alrighty, here we go. I've got to perimeter for this rectangle of 21 centimeters. I came up with that by realizing that in rectangles opposite sides have equal lengths. So I have 2 and 2 for these sides and 8.5 for the other two. 4 and 17 are 21 centimeters. For this one, in the hexagon, where all sides had the hash mark, that means all sides are the same. So we're 6 sides at 4.2 each. That's 25.2 feet. Okay, there's the perimeter for polygons. Add the sides. To find area, we got to just do a little back up and remember. We're going to talk about triangles and rectangles specifically. And I'm going to ask you to label here. This side is the height. The height is a segment that starts at a vertex and makes a right angle with the opposite side. That side that the height hits is called the base. So base and height here. And for a triangle, the formula for area, I bet you remember it. It's 1/2 times the base times the height. Another way of writing that is this: base times height divided by 2. I happen to like that one better. I think it's easier to understand. So when I'm finding the area for a triangle, I'm going to multiply base times height and divide by 2. In a rectangle, you can call any side the base and any side the height, because if you think about this, we start at a corner, we hit at a right angle. That makes that base and that height, or vice versa. It works both ways. In a rectangle, area is always base times height. You don't have to divide. That's only for the triangle. In a square, which is a particular kind of rectangle, base and height will be 2 of the sides, and since they're both the same, I'm going to call it base and base here. They're the same. The area will be the square of a side length. We ask you to find each area and perimeter here. To find perimeter, we want to add, and let's see, that would be 17 and 12.2, 29.2. inches. If I added right, I hope I did. 17 there, 29.2, yep. To find an area, we need to identify a base and a height, and we said that the base is the side that the height hits. That makes this a base, that makes that a height, and the area here will be 12.2 times 5.7. Since it's a triangle, divide by 2. Around 34.8, and since we are in area, those will be inches squared. Area is measured in square units. For our rectangle, it does not matter which side we call a base and which we call a height. What does matter, though, is that we get either all in feet or all in inches. We have to have the same unit before we start multiplying things. Now, I'm going to just say that 6 feet 3 inches is the same thing as 6 3/12 feet. 3/12 is 1/4. So this side in feet only is 6 1/4, 0.25 feet. Now finding the perimeter, we've got two sides that are like that. So two 6.25s and two 18 sides. That's 12.5, and that is 36. That gives us a perimeter of 48.5 if I added correctly. I hope I did, and those are feet. To find the area, it is base times height. So we are 6.25 times 18, and our answer will be in square feet when we get it. That is 112.5 feet squared. Very good. We're left with one more. I just want to remind you we already had these measurements. I know that this side was 6, and the hint here says find a convenient height. Ladies and gentlemen, a height starts at a corner and hits the opposite side at a right angle, and we have a really nice height right there. See, that horizontal line is countable. The vertical and the across, we can count those. So that height is 1, 2, 3, 4 units long, just by counting the squares. 1, 2, 3, 4 squares. To find the area for this, we multiply. It is a triangle, so we're going to take base 6 times height 4 and divide by 2, and that area will be that's 24 divided by 2, or 12 squared units. All right, we want to just take a second and look at area and perimeter formulas for circles. A circle can't be a polygon. Why not? Yeah, it doesn't have straight sides, okay? It doesn't have straight sides. So whenever we find the perimeter or the area for a circle, really we're kind of estimating. There are formulas for finding the perimeter, which is also called the circumference. Many of you will remember that, circumference. And for area, in circles, circumference is equal to 2 times pi times radius. Area is equal to pi times radius squared. Sometimes, since it's true that 2 radiuses equal a diameter, some people will use the formula pi times diameter for circumference. Both of those are right. They both return the same value. If we're going to find a circumference and area on this circle, we have the radius given as 5, so the circumference would equal, well, we have radius, so we want to use 2 times pi times 5. I'm going to leave pi in my answer. Folks, I know you're going to be tempted, so 10 pi centimeters is that circumference. You're going to be tempted to put in 3.14 there. I'm going to say you work harder if you do that. If we leave pi in our answer, all we have to do is multiply the number parts and remember to stick a pi on there, okay? The area for this circle, pi r squared, so we want pi times, and it's 5 raised to the 2nd power, which is 25. 25 pi square centimeters. We have one more to do, and I would love to have you do this one. I'll remind you that that 24 yards is a diameter. Will you pause the video and come up with your answers? Please leave pi in your answer. Okay, let's compare. The diameter is 24 yards in this problem, so I'm going to use this formula, pi times diameter, or 24 pi. The units is yards. The area requires that you know the radius, so I have to divide by 2 to find the radius, which is 12. 12 squared is 144. So the area in this circle is 144 pi square yards. All right, I'm going to ask you to get out there and do that. You try at your earliest convenience. I'll see you in school.